Next up is Luke. Luke's from Push Security, one of the friends of WithSecure. We're really grateful to have him here today to talk to us a little bit more about SaaS security, and more specifically, how you can abuse SaaS environments in a way to gain persistence that I don't think many people are talking about at the moment. So welcome, Luke, and thank you very much for being here.
Thank you. So hello, everyone. One quick point before I move on. If any of you have ever seen our company before, the website, or you go afterwards and it looks completely different, that's because this is effectively an unofficial new brand launch on these slides. Just don't tell my boss. But if you do go to the website and it looks completely different, that is why. So, pain in the SaaS, persistent access in the SaaS-first world. The first thing we're going to talk about as a quick agenda is, like, why should I care? Why should you care about this topic? Especially if you don't consider yourself to use much SaaS in a company. Then we'll kind of look at what are traditional cyber attacks. How does SaaS actually change this? You know, where does it fit in? What aspects of that does it change? And then we're going to look at sort of 5 persistence examples. There's really kind of 3 core different ones and one key one there that's got about 3 different flavors. So we'll look at those as the main sort of technical dive part. And then we'll consider very briefly how this kind of impacts incident response and come to final thoughts and questions. So first of all, why should you care? I mean, before I even get to that, like, what is SaaS? I mean, you could probably define it in a few different ways. For the purposes of this talk, I'll probably be saying pretty much any business app that you use but don't host yourself. So, you know, that could be anything from, you know, the very core foundations such as like Azure, Microsoft 365, Google Workspace, those kind of things, and then anything else that you might use alongside that, like Slack or Dropbox or 1,000,001 SaaS tools that may even plug into that. But in terms of why should you care? Well, SaaS use is rising rapidly. I think it was a trend that was occurring anyway, and then I think with the pandemic sort of catapulted it further because a whole bunch of people that weren't set up well for remote working suddenly needed to find ways to work more easily, and that made it easier. And at this point in time, I think actually a lot of startups, or at least tech startups, many of them are either SaaS first or SaaS only. I mean, we as a company, we are literally SaaS only. We don't have any infrastructure whatsoever. I don't think we don't even have a virtual machine. Even our production infrastructure is all like AWS Lambdas and that kind of thing. So, you know, this is kind of the inevitable shift of technology here. And even in the enterprise space, I think we're seeing quite a lot of migration to different SaaS services as you get towards the enterprise space. And the other aspect is that I think when you get into bigger companies that maybe have not sort of officially started adopting lots of SaaS services, the reality is there's a lot of shadow SaaS use generally. In our experience, when we've dealt with large customers, there's a lot more SaaS use going on the ground level than maybe the top level realize. And I think, to be honest, SaaS companies are kind of taking advantage of that to some extent themselves, in that it's much easier to get around procurement teams when you've basically managed to get a whole bunch of people in the company already using it and dependent on it, and at a certain point it becomes inevitable that it has to get adopted and paid for more, rather than starting at the top level and jumping through the procurement hoops. So if someone in a marketing team decides to start using Canva or whatever tool, then, you know, that's great from a SaaS company's perspective, and so I think that's one of the reasons that we're also seeing a lot of increase in use here. So, you know, if this is happening and it's a kind of an inevitable technological shift, then, you know, it will impact security. There are new attacks that come into play. It does change certain things, and obviously, as security professionals, we need to be aware of those things and make sure that we factor them into our planning. So if I think about traditional attacks, because I just want to kind of consider this example first to be able to contrast it with how SaaS fits into this, I'm kind of thinking of an endpoint compromise scenario here. And it's funny that I'm actually describing this now as a traditional attack, because I can remember being at a briefing like this many years ago and describing this scenario as the more modern attack. And now I'm standing here, sort of fatter and uglier than I was then, saying that this is now the traditional attack and there's something else new coming along. But yeah, I'm thinking here of a traditional kind of phishing attack to targeting an endpoint. get an implant to run on that endpoint somehow through some kind of code execution. Maybe it's a macro or whatever, and then an attacker might install persistence mechanisms on that laptop, then move laterally within the organization, escalate privileges, eventually move towards their objectives. Perhaps there's some confidential files on a file server they want, or there's a banking app they need to get access to, whatever the case. This is something that's become mainstream for many years now, and it's spawned whole industries, like the entire EDR and MDR industry has been focused a lot around these type of attacks. So this works, especially against large organizations. That's why it's become such a common attack. But this is what I'm considering as the sort of base example, and I want to see how SaaS kind of fits into this. So I think the first thing to consider now, I'm kind of trying to think about this in line with the kind of cyber kill chain example. So that's like the original Lockheed version of it, and that was very much tied into the idea of endpoint compromise scenarios. And there's a quote here, identity is the new endpoint. I don't know who said it. It's one of those things I've heard a few times now, and I don't know where it came from originally. I've been saying it, I've heard other people say it. And it does remind me, if I look back to that example before where we moved from the sort of traditional web attacks and server attacks towards the endpoint compromise scenarios, at that point, the firewall was no longer the be-end all of the perimeter, and people were saying the endpoint is the new perimeter. And I think what happens now in the SaaS space, it's really the identity is the new endpoint, and that's the kind of space we're moving into. So if you think about it from a sort of cyber kill chain perspective, you can fit it in various ways here. I'm going to focus just on one area today, but just briefly, if you consider the sort of delivery and exploitation side of it, you could consider consent phishing, for example, which was spoken about in the talk previously. That's one way of compromising a user with a slightly new take on phishing, which makes use of kind of authorization mechanisms via OAuth, getting into Azure or Google Workspace. You could think about it in the command and control channel phase. And for example, WithSecure has a framework called C3, for those of you that are familiar, that enables people to develop lots of different flexible plugins for having command and control channels. And so instead of the old school way of having a unique domain that's used as a callback for an endpoint compromise that can then be detected as a new domain and blocked, people can use Slack as a command and control channel, or Teams as a command and control channel, or something like that. And that's making use of SaaS in that space. And then you can't really easily detect and block something like Teams if that's what your organization uses as their legit communication. So that's kind of fitting in to that space. But today I'm going to focus on the sort of persistence phase. One is time. I've only got so much time. I wanted to just focus on one area. And two, I think from my perspective, it's the kind of phase that's been maybe ignored slightly or kind of slipped under the radar a little bit in the news space. So, people talk about consent phishing. People have been using Slack and other channels for comms for a while, but I think the persistence side has maybe not had quite as much limelight. So that's why I sort of chose to factor that in. So I'm going to start with one very simple example. Then we'll move to the sort of three different flavors, slightly more technical, and then we'll do a simple example at the end again. And I'm going to start with something that's just mail rules. So this is something that impacted pre-SaaS as well. But a lot of people now, even large companies, are often using like Microsoft 365 or Azure for their email presence, or maybe they're using Google. We tend to observe smaller startups on the Google side and larger companies on the Azure side. But there's a perfectly good, legit reason for mail rules. I'm sure everyone here has used them at some point. And generally, it's you've got a spammy colleague or team, and you want to put emails from them into a different folder, or you're on a holiday and you want to redirect your emails to your colleagues or teams to handle. Very useful functionality. The difference is now with things like Azure and Google, it lives on the server. Those things run on the server. And from a malicious perspective, so we're starting from an example here where we've already compromised the user somehow. Maybe we've compromised their endpoint, or we've hijacked their session in some way. And so we're talking about how do we maintain that access so it's persistent. So I'm in control of a user's account at this point. So rather than put a registry run key on their laptop or something to maintain access to their device, I'm thinking about the sort of SaaS and identity-based persistence. And so with mail rules, you can do things like create something that's going to forward password reset emails to you. I mean, that's a particularly insidious one. You gain access once, do that, and then that's a way of accessing lots of other SaaS services that the user uses as well, because then you can go and trigger the password reset functionality for lots of other SaaS services they use, and get access to those emails to then actually log in as the attacker. And you could even set up rules to delete the warnings or the other things as soon as it's happened, so the user isn't even aware. Or it could just be simple things like matching on keywords like confidential and forwarding the emails on, or doing things for invoices to forward them on if you want to try and change account details to hijack money. Whatever the case is, there's quite a lot of sort of malicious scenarios that come into mail rules, and then you've got essentially a 24/7 hosted service operating them for you after that. You don't need to stay on the user's endpoint. You don't need to know their password in future. Once you've set those things up, if they're not uncovered and changed, then that's a form of persistence. And quite a really simple one. It's almost like it's kind of really obvious, but it's something that I think is often overlooked maybe sometimes. But then if we move on to a second example, this is where we're going to get onto the OAuth front, and obviously there was some discussion around this with consent phishing before, and this is related in this way, but we're going to talk about it from a persistence perspective. So first of all, we'll just say, what is OAuth? So it's essentially an industry standard protocol for authorization. So if you think about many years ago, you wanted to give another supplier access to your data, you might have to set up something manually, or you might have to create an API and share that with them, or maybe at least generate some credentials, some sort of API key to give them to access stuff, or a user might just give them their username and password, which is obviously not something we want to happen in the security world normally. Those are the kind of ways it happen. But with OAuth, this was basically created to sort of solve this problem, to make there be a much more flexible, fine-grained way of delegating access to other providers. So essentially, down to the individual user level, you can selectively grant access to your data to third-party apps. So any user, generally by default of, say, Azure or Google Workspace, for example, can then go and grant access to maybe their files, maybe their emails, maybe their calendar, depends what it is. So you will have almost certainly made use of OAuth, even if you don't really know the word itself or what it is. If you've ever seen a website where it allows you to sign in with Google or Apple or Microsoft, Facebook, whatever, that's a social login. It's implemented using OAuth as a way of verifying your identity using your existing account. If you've ever made an integration with any apps like that then ask for permissions to access your data, like you're seeing on the right for Slack there, that's a Slack app that I've integrated for myself, and I'm granting access there. That's also OAuth. Even things like smart TVs or other limited devices, like where you don't have keyboards, there's different flows using OAuth to make it easier to grant access to things, where rather than have to type in a long password on something that doesn't have a keyboard, you can basically delegate that to another device and enter a code on your phone and approve it and authorize it. That's OAuth as well. It underpins quite a lot of things. So we're going to consider about how that factors into persistence here in terms of like delegating access to another third party. So the first example I'm thinking of here is a custom OAuth integration. This is the one that most closely aligns with the consent phishing scenario we saw earlier, because essentially this example can be used as a phishing attack, but it could also be used as a persistence attack. So in a phishing attack scenario, you've got to convince the user to do this for you. In a persistence scenario, you've already compromised the user somehow, and you're just looking for a way to maintain access to their data, so you can do it yourself. So in this case, as an attacker, I create my own new OAuth app. I request whatever permissions I want. So if I've got, when I get to pick, I'm probably going to say, well, everything interesting, email, files, SharePoint, a lot, I want it all. And then I can just go and manually OK that and click approve on a consent screen like you saw on the previous one. And I think if you're comparing this to the sort of endpoint scenario, this most closely aligns with the idea of having your own custom implant. So you've made it from scratch. Therefore, you have the benefit of being able to do whatever you want. But then if someone's looking for it, you've got an IR person or a threat hunter after you, it might stick out as being weird because it's not seen elsewhere. It's not normal software. You know, be like, what the hell is this random OAuth integration we've never heard of? Doesn't turn up any hits on Google. What is it? You know, that's the sort of downside of this, is that if someone is looking for it, then it may very well be unverified. It's certainly something you're probably not going to have in use elsewhere. But it's the most flexible in terms of you can do what you want with it. And that's one way of gaining access. And once you've done that, you don't need to maintain access to the user's password or their endpoint. Once you've set this up, just from the privacy of your own home and your own device on the internet, you can maintain access to the data that's been delegated. Now, there's another couple of takes on this, though. So if you think, okay, well, I'm dealing with a more sophisticated organization that's probably going to spot this strange OAuth integration, you can also use SaaS platforms themselves as a way to sort of maintain access to data. So I've picked, you can do this with any platform that has the functionality you want. I've picked Canva just purely at random because it happened to have some functionality that I wanted in this case. But if I go and integrate Canva as a platform, as a user, then it has the ability to request access to my files, say my OneDrive. And the reason Canva would do that as a platform legitimately is because it wants to allow you to be able to import and export files from Canva easily. And rather than have to constantly copy things back and forth, it has the integration there so that it can just do it through your OneDrive like everything else. Perfectly useful feature, perfectly legitimate. But there's nothing stopping me as an attacker from going and signing up for my own Canva account. Then if I have temporarily compromised my victim's account, I can then set up the integration there. And then if they're looking at their OAuth integrations, it's going to be a legit, verified Canva integration. If I'm being particularly sneaky about it, I'm going to pick SaaS apps I know they use. Like if I'm targeting a marketing team and I know they use Canva, for example, then maybe I will use Canva. Maybe they're already using it, so it's not going to look bad at all. It's going to look completely legitimate. So if someone's kind of investigating potential badness at that point, it's much more likely to fly under the radar. And then, again, I'm then constrained slightly in what I can do, in that I'm limited to what Canva allows me to do. But in this case, you can see, like, obviously, I can still go and browse their OneDrive. So it's still pretty powerful functionality. I can't do anything I want, but I mean, I've still got full file access, really. It's pretty good. So that's like one other take on it, I think, if you're trying to slip under the radar a little more. And so, you can look for platforms, and you can find multiple ones. If you go and pick a few common platforms, it might be that there's one that gets you the email access you want, one that gets you the file access you want, and whatever. Build them up, set them all up. Hopefully it looks more legitimate, and you've got multiple ways using legit SaaS platforms to get back into the data. So that's the second example. Sorry, one more point on this. I was going to say, if you think about this in the endpoint scenario, I think if I said before, the previous example was like having your own custom implant. This example is kind of like the TeamViewer example. It's like the living off the land kind of dual purpose tool type thing. It could be used legitimately, it could be used maliciously, and the difficulty is determining which is the case. So this is kind of like the living off the land approach. The third example that I didn't think of first when I was doing research for this, and then I realized was probably worse, is that there's actually certain scenarios where you can kind of genuinely control a legitimate app. So you almost get both benefits of the previous two. In this case, I've picked on Thunderbird, but it applies to lots of different OAuth apps. Now, Canva, when we're giving that example, we're talking about a web application. Lots of SaaS applications work that way. Now, we can set up an account and set up the connection using OAuth, but we obviously don't have access to their private OAuth secret, so we're limited to the functionality they offer via their SaaS service, and that's our constraint. In this case, if we're talking about desktop apps and mobile apps, many of these use OAuth nowadays for integration with certain data sets, particularly mail clients. And if they are using the confidential flow for OAuth, which is intended to be for the web app scenario, but realistically a lot of desktop and mobile apps use it too, then they obviously can't protect their secrets. Now, I've potentially been lazy by picking Thunderbird just because it's open source. It meant to get those secrets, I literally had to look at GitHub and search, find it. But I mean, there'll be lots of closed source applications where if you dig around and decompile it, you'll probably end up finding where these secrets are. The point is then you can essentially impersonate that app. You won't be able to use this for a consent phishing attack because you won't control the callbacks, but that's a different point. But from a persistence perspective, when we've already gained control of the user's account and we're looking to maintain that access for the future, we can use this attack. And it's not really any more different than just setting up a Thunderbird connection. The difference is we will take those credentials and write it into our own basic app to do the consent, and then we can actually do whatever we like. So in this case, not only can I call the APIs to query them in whatever way I like, I don't have to depend on what Thunderbird normally does. I've got the same level of control that I would have making my own custom app. But also, I don't have to stay limited to the permissions that Thunderbird requests. I can actually ask for anything because I control that too. So even though Thunderbird normally just asks for like email access and calendar access, I've gone and added loads of things, as you can see there, like SharePoint access, OneDrive access, AD access, and all those sorts of things. As long as the user can approve that access that I've got control of, then I can do that. And then I can list out whatever I want. And that's got a lot of benefits then, because then you essentially have, you've got that full level of control, but it's still going to fly under the radar more because it's going to look like something that's supposed to be legitimate. And there'll be many other examples beyond Thunderbird where you can do this sort of thing. So I've got a very quick, if it's going to work properly, demo. So let's say I'm logged in as a user I've compromised. I'm just in there, in their Outlook email, for example, at the moment. I then go to my own web app, essentially. Click to sign in. Now I'm already signed in, so I don't need to re-log in. So it's just going to straight away ask me for those permissions. As you can see, obviously there's lots of things added here that Thunderbird wouldn't normally ask for. So I'm saying, give me all your SharePoint as well, give me all your OneDrive. And then, okay, all right, just click accept. And then call the Microsoft Graph API. There I've just sort of proof of concept, pulled back the OneDrive files, but obviously I can go and do anything I want at that point. And then here's interesting, if I go to the Azure portal and look up that app now, it says it's Thunderbird, and if I go and take the application ID to kind of Google that, I'll find all the references to that normally for Thunderbird, because it is the legit Thunderbird OAuth app. So that is quite powerful, I think, using that type of technique. So that's another persistence example here. There's one final point on this. I've kind of talked a little bit more about the Azure side there, but obviously all of these attacks apply to Google too, but Google does admittedly do a bit of a better job on OAuth specifically. What Google have done is they've essentially said most kind of permissions that aren't that sensitive, you can delegate, and you can set up an app to gain access to those, to that data without going through too many checks in terms of verification. But if you want to access the most sensitive ones, which is generally like Gmail and Google Drive, those kind of things, they're restricted scopes. And you have to go through a very intensive process at that. Like if you're an organization and you want to make an app that integrates with Gmail, like there's like literally an approved set of pen test companies that you have to go and use and get pen tests and then get things that get authorized by Google security team and that kind of thing. So it's quite a lot of involvement at that point to get that access. But obviously, if you take something like Thunderbird, obviously that's intended to be used as a mail client, so they have been approved. So in that case, I can't go and get the files. I get that blocked bit if I try and use the Google Thunderbird app, for example. But I can still access the email, and normally I couldn't even do that with my own custom app easily because of the additional restrictions Google apply. So it's almost like some of these things will be an interesting way of kind of getting around some of the additional restrictions on Google Workspace too. So finally, I've been over the OAuth ones, and that was where there was a little more technical detail. Back to another really simple example that's really obvious in many ways, but again, I think something that's overlooked. When I used to be a pen tester, one thing I always found on internal networks was that file servers, like your traditional internal file server, used to generally have pretty poor ACLs in place. Like a normal user, if they made their way to shared drives, and same with internal SharePoints, realistically had access to quite a lot of data. There might be some key things they were blocked from, but if you start looking around, and certainly just simple things, searching for the word password, that kind of thing, you'd often find like there's a lot of interesting stuff there. But at least it was internal. Normally, You'd need a two-factor VPN to get to it, that sort of thing. The issue with things like OneDrive and Google Drive now is they're essentially normally internet accessible. They're most of the time people have set up two-factor, and there's a lot of good things about it. But the point is now we've got ways of sharing things with other companies, which is a great feature. You want to share a document with another partner company, rather than sending things back and forth via email, it's way better. But from an attacker's point of view, you get temporary access to something. You just go and share the root folder or share something else, make it anonymously. You can either share it anonymously with a link, or you can share it to a specific other tenant. And the point is, you've probably seen these things before. I've highlighted the ones that are shared. Lots of things get shared. It's normal to see that. How often are people actually verifying what's going on here? And that's permanent access at that point. You could just set it up on a folder, anything new that's created in it. An attacker can then come back to later and access. Don't need access to the user's endpoint, don't need their password. There's another case there where the persistence can be quite interesting with something really dead simple. There's nothing smart and technical about that. It's just any old user can do this as well. So there's another factor in here. I've basically talked through that already, apologies. Okay, we've seen 5 persistence examples there, sort of 3 with different flavors of the same, and then 2 other ones. So I guess the other question really is, how does this impact incident response? And I'm going to apologize to the incident responders who came before me by massively simplifying incident response into 2 points here. But from a back of the napkin method, I'm thinking if you're thinking about incident response normally, there's 2 particularly key things you need to look at. One is investigation, being able to go and find out what happened, and another is containment. How do you deal with it once you figure out what's happened? Most of the time on the investigation front, you're talking about logs of some kind. There's a million different sources of these, whether it's from forensic artifacts or sort of actual active logging mechanisms. We'd normally be thinking of endpoint logs, proxy logs, network logs, file server logs, all those kind of things. But I think the first question with the sort of things I've spoken about today is do you have logs for that? If you think in your own organization you needed to go and investigate this, would you know where to look to see those things? Because not all of them are easy to see in the sort of common examples. Some of them are. But I think the first thing to think about is just, well, from a visibility perspective, can we go and have a look at this stuff when we need to? And then from a containment perspective, obviously the scenario we saw before, we're talking about a very complicated incident response scenario. At that point, containment scenarios are very complicated and planned. But if we're talking about much smaller scale, kind of run-of-the-mill incidents, often where one individual user has a minor compromise, it hasn't gone any further. The most common things we think of are password resets, maybe an MFA reset too, and device wipes. So, okay, if the passwords have been compromised, well, we've changed those. If the device has been compromised and there's persistence mechanisms set up on the endpoint, we could try and clean up the ones we've identified, or we can just say, let's just be sure about it and go back to a fresh build. Those are 2 really common things that organizations do, but neither of them actually do anything about these persistent scenarios in this case. So everything that we've just looked at is essentially is not affected by these 2 things, because they don't require a password and they don't require access to an endpoint. So that's why I think they're particularly important here, because I think they often fly under the radar of a lot of normal kind of procedures. So really, it's just a case of figuring out how do we put these things into our IR playbooks? How do we factor this in? So just a couple of examples of some extra things that you can see here. On the Google side, I've focused on the OAuth examples here, but the top left, I've got a small snippet from Google. If you've got the right license for Google Workspace, like an enterprise license, or I think some of the education ones as well, you can see API level data for OAuth. So if an OAuth app accesses a file, for example, or accesses your email, you can track that back to which app did it separately from users. So that is something you can do with Google Workspace. Microsoft does have similar functionality, but in a different way. So rather than separate it into a separate OAuth thing, they've kind of integrated it in with their general logs, which arguably is probably better. So if you use Microsoft Purview or something, can you get some of the Microsoft logs? In this case, I've got an example of a file being downloaded. It's basically the same event you would see if you went to the OneDrive web interface and clicked to download a file, except when an OAuth app does it, you get this additional app context. So you can then see that, one, it was an OAuth app that did it, and the client app ID there, you will see a unique identifier, which will tie that back to the actual individual integration that did that. So if I use my Thunderbird malicious version to go and download all your files, you'd see the Thunderbird ID in there as being the one that's accessing all of those files. Also, in terms of like actually kicking an attacker out when it comes to things like mail rules, document sharing links, and OAuth, obviously mail rules you'd need to audit and remove. For sharing links, you'd obviously have to revert them. But with OAuth apps, you'd need to like delete the integrations and like delete the refresh tokens. Microsoft, for example, if you go through the Azure portal and find an OAuth integration there, annoyingly, you can't do it through the web interface for some reason, but it gives you PowerShell scripts to run, so you can then go and like revoke the permissions, but also revoke all the refresh tokens and that kind of thing, so you can clean up. And really, that should be like a key part of a normal IR process for like cleaning a user account. It's the same way that if you had a situation where, okay, you've got to reset the password, do something else, like deleting all the refresh tokens for OAuth things should probably become standard at this point as part of that kind of thing. So, okay, final thoughts. So to kind of zoom back out to the high level, there's a lot to talk about in terms of SaaS security. I've sort of focused on one small little area of it today just to give a kind of a little taster of how it's changing things and how to be aware of it for the future. But I think the main key takeaway point is that SaaS adoption is inevitable anyway. It's a massive technological shift. And in the security world, even if we don't like that, it's going to happen. So we've got to deal with it. In smaller companies, it's just the norm now. It's like the normal practice for how smaller startups and stuff work. Enterprises are moving that way. So really, it's just a case of, well, there's a good reason that's happening. It's because SaaS services are really useful and they're really efficient and effective in many cases for like adopting services quickly. And that's why there's a reason technology normally succeeds. And so there's a good reason here. And really, we don't want to be looking at this from a perspective of how do we block our users from doing these dangerous things. It's going to happen. They want to use it for good reason. So really, we just need to incorporate it into our security strategies and factor it in just the same way we did when people started getting laptops and endpoint compromises became normal. We just figured out how to deal with it. And that's really, I think, the key take home here is like SaaS-based attacks and SaaS use just needs to be part of your security strategy overall, and particularly your detection and response strategy in the same way that endpoints are and have been for some time, and in every other aspect of security. So that's really, I think, the main point to take away. And move to questions in a sec, but just as I said, like there's only so much I could talk about today. If this kind of area interests you, I've written a few other blog posts on the wider area. So like one of the blog posts I've just put up here is essentially very similar to this talk, like the persistence one. But when I mentioned things like social logins, but didn't talk about them too much, and just general legitimate integrations, and also if you were looking at integrations you already have, like how do you know what's good, what's bad? There's a few other blog posts up there about those kind of things if it's of interest. But otherwise, yeah, that's it. And thank you for your time. And I'm happy to take questions now.
Thank you, Luke. So does anyone have any questions for Luke? There's a hand up over there. Please wait for the microphone. That's all the value that I had on.
Hi, yeah, thank you for the talk. I appreciate it won't be a silver bullet, but how far do you think implementing things like SSO and conditional access would help in these scenarios?
Okay, so you're talking about for Azure, right?
Primarily Azure, yes, but yeah.
Yeah, so you can, I think some of the things that are quite successful as a good kind of middle ground that I've seen people do here is try to take things like conditional access policies to maybe identify the most high-risk permissions on this. Again, we're talking specifically about the OAuth issue here, but take the highest level permissions and say that kind of needs a sort of review and allow all others. Because the thing is, whenever we've looked at companies, there's so many OAuth integrations, really, you want the majority to pass through okay. And the majority tend to be quite low risk as well. Like the majority of integrations we see are pure social logins, which mean they don't actually really give away any access. So yeah, I mean, I think if you want to have a little bit more of control over that, then using something like those approaches, but just trying to pick on the most sensitive ones to get a second set of eyeballs on from IT or security before that gets auto-approved, then yeah, like, it's probably quite a good thing to do. And we have seen certain people do that. And I know certainly Microsoft have made it a bit easier to do that over the time, as you can sort of divide things into low risk, medium risk, high risk things and set different strategies for that. So yeah, like I would say it's quite useful to use those kind of controls.
Thank you.
Anybody else? There's a hand at the back, and then Daniel at the front.
Hi, thank you for the talk. I'm just curious, in terms of every SaaS solution has its own way of like logging and how much they log in detail, like do they source IP, the user logging and so on. How would you recommend people, companies actually centrally collect that information to then triage it? So what would be the approach?
I mean, if you're talking about the wider SaaS if someone's using 100 SaaS apps, how do you get all the information? I mean, it's a very hard problem, and one I think is going to develop rapidly in the industry. One of the things that is good about, say, social logins with OAuth, as opposed to so social login means you log into another SaaS app using your Microsoft account or your Google account instead of setting up a new password. Obviously, you don't need to then worry about managing multiple passwords. That's nice. But the other thing is it gives you at least login level visibility via Azure or Google Workspace. So if you actually so one of the things in my article there is that a lot of people have sort of been distrustful of social logins before. And I was guilty of this myself. I never looked into it for years. I was like, I'm not logging in with Facebook. But like now, actually, I use social logins quite a lot. And if you encourage users to do it that way, you actually get easier visibility of what everyone's using, and then you can at least see when they've logged into certain things. Obviously, it doesn't solve the wider problem of if they're using Dropbox, exactly what files have they uploaded and downloaded. There's no easy solutions for that. But I think definitely social logins are helpful for at least getting a little bit more of a view on that. And then it's good for when employees leave as well, because if they leave, their account doesn't stay active. Yep. So that's there's another benefit there too.
Yeah. Thank you.
I think there was a question at the front. Okay. Anybody else? One more question? Okay. And we'll let you off the hook. Thank you very much.
Awesome. No problem.